everyone. In this video, we're going to perform another lathe simulation operation. To achieve this kind of output, the first thing we're going to do is to compute two things. The first one is we're going to calculate the spindle speed for our lathe machine. The second one is we're going to calculate the taper angle that will be used in our taper turning operation. And lastly, we are going to study these given dimensions and perform facing, turning, and one of its method, which is taper turning, and lastly is the undercutting to achieve or to attain this kind of output. Without further ado, let's get started. Now, we're going to calculate the spindle speed that we are going to use in our lathe machine. So the formula of spindle speed is 1000 times the cutting speed all over pi times the diameter. For the cutting speed, we are given a material which is mild steel. So we're going to use the cemented carbide tool because of its characteristics, which is because of its hardness and its strength. So the mild steel has a cutting speed of 90 to 150 meters per minute in cemented carbide tool. So we're going to input 90 meters per minute in here. And for our diameter, in our lathe machine app, we are given a raw workpiece dimension which is 100 by 30 millimeters. So we're going to use the 30 millimeter diameter in here. So 1000 times 90, that gives us 90,000. 3.14 times 30, that gives us 94.2. So 90,000 divided by 94.2, that gives us 955.41. So let's just going to use the 955 RPM or 955 revolution per minute. So this is now the value of our spindle speed that we are going to use in performing the lathe simulation operation. The second computation that we are going to perform is for the taper turning operation. One of its method is the compound rest method. In here is our given output dimension. In this area is the angle that we are going to compute using the compound rest method, using the formula of arctan times 1/2 times the taper ratio with the formula of the large diameter minus the small diameter all over the taper length. In our output dimension, it has a large diameter of 28 millimeter and a small diameter with 22 millimeter and its taper length of 30. With these values, we're just going to input everything into our formula to get the angle of the taper. And into the calculator, that gives us arctan times 1/2 times the taper ratio, which is 28 minus 22 all over 30, and that gives us an answer of 5.71. We now have an angle of 5.71 that we are going to use when reducing the diameter of our workpiece. Now that we are done with our calculations, we are now going to study these given output dimensions before performing it into the lathe simulation app. In there, we are given a raw workpiece dimension of 100 mm in length by 30 mm in diameter. For our toolkit, we are going to select the cutting tool number 5 for facing and turning operation, and also cutting tool number 43 for grooving operation. Let us also not forget our taper angle we have calculated earlier, which resulted to 5.71, or we can round it off up to 6. So the sequence of operations that we're going to perform, the first one is the grooving. This is the area where we're going to perform the grooving operations. It is also termed as undercut because when grooved that and is cut next to a shoulder, it is termed undercut. So to perform the undercut, we're going to move the cutting tool number 43 up to 23 millimeter longitudinally. Why 23? Why not 20? Because we have to consider the cutting tool dimension. It has a diameter of 3 millimeter. And moving it transversely up to 18 millimeter to attain this diameter of 12. And moving it again longitudinally up to 32 millimeter. The next operation that we are going to perform is turning. The first turning operation that we are going to do is reducing the raw workpiece diameter of 30 millimeter by 2 mm to make it 28 millimeter, which is our largest diameter. The second turning operation that we are going to perform is reducing the 28 millimeter up to 8 millimeter to make it 20 millimeter diameter. Let us not forget that our cutting interval is only 2 millimeter. Because if we're going to do big proportions, the tendency may be it will break or damage the cutting tool. So the next operation that we are going to perform is the taper turning. This is the area we're going to perform our taper turning. So the first thing we're going to do is set the angle to 6 degrees. And after that, we're going to calibrate and move our cutting tool number 5 up to 6 millimeter to make it 22 diameter After that, we're going to move it longitudinally up to 30 millimeter in taper length. So the last operation that we are going to perform is the facing operation. So the raw workpiece length is 100 millimeter. But this output dimension has only a total length of 82 millimeter. So there's going to be an excess of 18 millimeter. So that is why we're going to do facing operation to remove this excess. So this is what we're going to do in our Lathe simulation app. So let's get started. So now we are ready to put into action everything we have computed, everything we have studied from our output dimension. So before we start turning on our machine, let us first prepare it by changing our spindle speed according to what we have calculated earlier, which resulted to 955. But I think the closest that we can use is 800. The next step is we're going to change our workpiece dimension into a 30 millimeter diameter, and we're going to offset our workpiece material to the farthest it can go. Okay. For our toolkit, we're going to select the cutting tool number 5 for facing and turning operation and the cutting tool number 43 for the undercut. So now we are all set and prepared, so let's turn on our machine. Let me change my view to top view and turn on our spindle. Let me change the camera to number 2. But before I forget, we're going to choose the cutting tool number 43 first, because the first thing we're going to do is the undercut. Now we are ready to do the calibration. To do that, we're going to move our cutting tool close to our workpiece. So now we are too close. We're going to calibrate it manually until we hear the cutting sound. So the technique that I'll be using is when I calibrate, I'll be using the back portion of my workpiece because sometimes we do commit errors or mistakes when calibrating. We may accidentally move it into point 1 and that will leave an error to our finished output. So I'm just going to do my calibration on the back portion because later on we'll be doing the facing operation. So that's our 0 right there. And for the transversal movement, just gonna change it to 0.5 and calibrate it slowly. Okay, that's too much. Okay, that's our 0 right there. So now we're going to reverse. And I'm going to start the first operation that we're going to do, which is the undercut, moving our cutting tool number 43 to 23 millimeter in length. Okay, and we're going to move our transversal movement up to 18 millimeters. Stop. Do it manually. Okay, that's 8 millimeter. And we're going to move our longitudinal movement up to 32 millimeter to make the length of 12 millimeter. Okay, that's 32. Before we proceed to another operation, let us check if we got the right measurement for our undercut. This should be 12 millimeter diameter. Check. And for our length, this should be 68 millimeter, and this should be 80 millimeter. Okay, and that gives this and 12 millimeter in length. So the next operation we're going to do is facing. So we're going to use the cutting tool number 5. So to do that, we're going to perform the turning operation. First thing we're going to do is calibrate. So in calibration, as what I have said, I'm going to use the back portion of my workpiece. Okay, that's our 0 right there. for our transversal movement. And we're going to move it 0.5. Okay, that's too much. So that's our 0 right there. So now we're going to perform the turning operation, and we're going to reduce this 30 millimeter diameter up to 2 millimeter to make it 28 millimeter diameter. So we're going to move it 2 millimeter for our transversal movement. And now we're going to start cutting. Before we proceed to another turning operation, check if we got a 28 millimeter diameter. Okay, good. So the next step we're going to do is another turning operation, reducing this area right here to 20 millimeters. So we're going to reduce 8 millimeter. To do that, we're just going to use the cutting tool cutting interval, which is the 2 millimeter. Plus 2, that makes it 4. Another 2, that makes it 6. For the last 2 millimeter, that makes up a total of 8 millimeter. Now let's check using our vernier caliper if we got this 20 millimeter diameter. Okay, good. So the next step is for our taper turning. So in order to do that, I'm just going to move this transversal movement, reducing it 2 millimeters, because our diameter for our small diameter for our taper is 22 millimeter. So I'm going to move it to 6, and for our longitudinal movement, I'm going to move it up to 32 millimeter. And I'm just gonna leave a small mark indicating that's a 6 millimeter right there. Just a 0.1 mark. Okay, that's already enough. Now let's check. Okay, that's 22. So now we're going to set our angle to negative 6 degrees, and we're just going to move our cutting tool based on what we have, based on the mark we have got earlier. Okay, just move it. Let's see. I think this is it. Okay, using the chamfering hand lever, we're going to move it. Now let us check. This should be 38 millimeter, good, and this is 22 millimeter. Now we're just going to move our cutting tool further away from our workpiece and set back the angle to 0, because the last step is we're going to do the facing operation, reducing our workpiece material up to 18 millimeters to achieve a total length of 82 millimeter. So to do that, let us first calibrate. Okay, that's our 0 right there. Do a 0.5. Oh my god, sorry. 0.5 right here. Just going to do 1 because I accidentally. Okay, that's our 0 right there. So I'm going to move the workpiece up to 2 millimeter for our cutting interval and do the facing operation. Before we proceed with our remaining 16 millimeters, let us check if we got a 98 millimeter for our length. Okay, good. So now we're going to proceed to another 2 millimeter. That makes it 4. Another 2, that makes it 6. Another 2, that makes it 8. Another 2, that makes it 10. So let me check first if our total length will be 90. Okay, good. Now let's proceed to the remaining 8 millimeters. So this is now 12. Another 2 millimeter, that makes it 40. So another 2 millimeters, that makes it 16. On to the last 2 millimeter, and that totals to 18 millimeter. Okay, now let us check. For that, let me reverse this one. Let us check our measurements. Okay, we got a total of 82. Okay, good. The next will be 62 millimeter. Good. And the next will be 50 millimeter. Good. And the last millimeter would be 20 millimeter. Good. And now for the diameters. The first diameter will be 28. good. The next will be 22. Okay, good. The next will be 20. Okay, good. And the last will be 12. Okay, good. So this is what our workpiece looks like, performing the undercut and the taper turning. So that's it. So before we end, let us open the feed selector, because this is where the debris or the excess of our workpiece material is located. Okay, so that's it. That ends our video. Thank you for watching. Bye.